的讲说。感谢4位讲者的专业演说。那接下来是我们的 Q&A 时间。我们请讲师上台。然后因为时间的关系，我们是开放3个问题。如果后续还有需要跟讲师讨论的话，我们可以在会后可以跟讲师留下联络资讯。各位嘉宾谁有问题吗？或者是任何的意见都可以提出。有问题吗？
大家赶快抓紧机会问既然来的，对不对？有的还有从高雄来的，跑那么远，总要有点收获。
Hi, I'm Jimmy. Do I need to speak in English?
Okay.
Okay, sure. I want to ask about how do you plan, because in our company we have a lot of service that have different pattern or workloads. So how do you prepare or plan the topology when you deploy those kind of service on Kubernetes? Yeah, thanks.
Yeah, I guess I can answer that a little bit. So there's a few different things you can do to kind of help, plan that. That might be, I'm not sure like which type of, aspect you might be talking about, but certain things like how much each, application, how much each application uses in terms of resources throughout that little cluster, as well as we're doing this live. So I guess the topology is going to be pretty application specific. So it's kind of hard to say like there's one way to define the right topology, but generally like people kind of take a microservices style approach to developing applications in something like Kubernetes, right? So you essentially have each application does, performs one specific function, and then each of the applications can kind of scale independently of each other, so that if one in particular needs to be accessed or has a lot of load going to it, it can be scaled independently from other ones that are not really getting as much load or whatever. And so people tend to kind of take this microservices approach because it fits really well into the idea of, say, like having a group of containers that you for that particular service, and then putting like kind of a service discovery mechanism on top, like Kubernetes services. So combining them like either the replica sets or deployments in Kubernetes with services for each microservice, and then kind of putting those together. That's generally like the basic way that people kind of build their topologies, but the individual topology for each application is going to be very application specific. I hope that answers your question. If you guys have anything to add, that's cool with me.
那我可以听听看其他3位讲者的意见，就是说，如果我要在 Kubernetes 上面部署我的各式各样的 service， 有不同的 workload， 有可能有 batch 的，有 stateless service， 然后可能有 streaming application， 那这个部分你们大概会怎么样去事前做规划、做安排的？
基本上我们公司的话，我们会直接在我们自己 bare metal 上机上做一些测试，就是直接做压力测试去验证说每个节点，应该说每个 service 它的服务上限它大概是多少，那以及它可接受的一些 CPU 的 resource management， 它的 limit 到底在哪里？那基本上做完以后，我们就直接放上去 production 去再验证一次我们到底是正确的。那其实因为以 Kubernetes 来讲，它的整个升级跟 rollback 其实非常完善，所以其实如果你真的设定错误了，基本上你还是可以在短时间内恢复正常运作这样子。对，那我觉得你们真的要去做不同 workload 测试的话，其实我觉得最方便的方法就是你就直接跑完看，因为我觉得用压力测试去验证说你的服务的 bottleneck 在哪里这件事情比较重要。其实我们没有办法光靠用纸跟笔就计算说我们的服务的 bottleneck在哪里这样子。谢谢。
这边的话，我觉得有几种状况，因为 depends on 你现在 application 的应用，跟你现在整个所谓你系统的整个架构。那有些时候，其实我觉得像有些 service 其实是比较适合放到 Kubernetes 上面现在跑的。那除非说你今天想要跑一个 stable， 这个目前我还没有在上面试过。那接下来会去尝试来做这件事情。那再来看在 stable 上面是不是？因为我们刚才金山有讲过说，因为我们如果说今天我们要做一些 transaction 的事情，你会敢把资料放到上面吗？因为它可能没有办法帮你做备份，没有办法做成 snapshot 的一个部分，其实风险是比较大的。所以目前我会建议是，你一样再把你 stateless 的部分部署在 Kubernetes 上面，用 container 的方式。那一些 database 的部分，你可能用 bare metal 或者是用其他的一个方式，甚至用OpenStack VM， 它有帮你做一些保护的东西。那这样子整个机制建制会是比较完整的。那当然你也可以尝试看看，但是就考虑到那个风险跟你所要尝试的那个代价会是什么。这是我以上的想法。
好，他刚一开始的时候我是第一棒嘛，现在换我最后一棒。所以最后一棒的话，我就等于是补充跟结论啊。其实刚刚一开始前面几位都已经说到了嘛，我们不同的 service 的话，基本上 test 一定要跑，因为你要先看你的 workload。那刚刚我们谈到的 workload， 可能都是 focus 在你 CPU memory。好，可是那你实际上你的 bottleneck 到底在哪里？你会不会是 I/O 棒？你会不会是 networking？ 所以这个东西你要先搞清楚，不然你怎么弄都弄不起来。那先搞清楚你的 service 到底是 CPU 棒、memory 棒，还是 I/O 棒，或者是 networking 棒。那了解这件事情之后，下一个阶段就是所谓的 capacity 的 planning。好 ，capacity planning 下去的时候，你就会知道说，那我该怎么去分布，我要怎么去放。好，然后我要怎么去布，像可能我要选 VM 啊，或者是我要直接 bare metal 刚刚提到的，或者是说那个你要是放在 container 上面，然后呢，那你底层的部分你 storage 的时候怎么接？因为有时候我们往往发生的时候，你实际上真的 concurrent 打下来的时候，你会发现说你真的死人，你死的是 I/O 棒，所以你这个东西你给它再告 CPU， 你可能问题不会被解决。所以基本上整体而言，你先第一个压测一定要做。那测的话，你可能会需要不同的工具。好，如果是你知道测 CPU 或者 memory， 你可能需要一些 benchmark 的工具。如果你是要做 IOPS， 你可能靠 FIO 或是这些东西。那你先去了解整个 service 的你的 bottleneck， 然后再来之后你做 capacity planning 之后，你的准确率就会比较高。那做完之后呢，实际上我 run 上去之后，可能我还是要去做一些performance tuning， 可能要去做调整一些东西。对，那这个东西要调的空间就很多了，所以基本上最终还是看你的服务是什么。因为你如果有给出明确的服务的话，基本上以我们公司而言啊，如果你给得出明确的服务的话，我们可以去帮你做进一步的分析。
还有哪里有任何问题吗？
我直接问好了，因为这个是 Kubernetes 的场景，所以我想问一下，如果说它跟 Dark Swan 做比较的话，你们可以比较一下这两者的优胜劣败吗
？You want to see a comparison about Dark Swan and Kubernetes?
Alright, I can maybe talk a little bit about that. I mean, I can say from the beginning that I'm not really a Docker Swarm expert, but just in general, there's a couple of things that that are kind of slightly different in terms of the way that each are architected. So Kubernetes is essentially architected in a way that's very like not necessarily monolithic. So it's got a lot of different like kind of agents and services that they can install, and that's partly so that the different applications have proper separation of concerns. So on each particular Kubernetes node, for instance, there is a kubelet which runs the containers. But the kubelet doesn't care anything about networking, right, between the containers. So that's handled by a different application called a kubeproxy. What's called a kubeproxy. It doesn't actually proxy any traffic, but it does things like sets up IP tables and sets up the networking so that the pods can talk to each other. And then there are various other agents you can run on the machines. But then on the API server, there's also a number of different components, right? So Kubernetes has an API server, which all it does is does the API, right? And then it has another service called the controller manager, which contains a lot of the controllers, which are a way of doing asynchronous type of work. So if I create an object in the Kubernetes API, all it does is create an object and store it in the cluster. So I say like, create me a pod. That's just going to save some JSON data in the data or in an XZB database. Like it doesn't in the API. It doesn't do anything. So like what happens like for like say controllers. So say something like a deployment or a replica set. Those have a controller that's part of the controller manager that actually creates the pods and does all of the interesting bits, like kind of in the background. So all of the pieces are kind of very decoupled, and that allows the application to kind of scale better and to have kind of better architecture and separation of concerns. Whereas something like Swarm is a little bit more monolithic. It's a little bit more, but in that sense, it's easier to set up, right? So installing Kubernetes is a little bit of work because you have all of these different components you have to kind of set up and get working. Whereas Docker Swarm, you can run it, like there's a few commands that you can do to like set up a cluster. And then it stores all of the state as the API server in those individual machines, whereas Kubernetes has it as a separate kind of master API server. So like, and Kubernetes like allows you to kind of architect how you set up your cluster in a lot of different ways. So you can set up your XZD to be on a completely separate place. You can have your API server and scale your API server completely different from your actual nodes. So like all of that is kind of has a very flexible architecture, but it's less geared towards kind of ease of use and user experience or developer experience, say, like, for setting it up. Whereas Docker is much more focused on that aspect, making it easy to set up, but maybe it's a little bit less flexible with when you get into very large clusters and that sort of thing. From a user's point of view, they're somewhat similar. I think Kubernetes has a lot more features at this point still. Docker is working on having a lot more features that, but I think just in general, the main difference is kind of the architecture and how the different systems are set up. That's just my take on it.
那因为其实我能够琢磨不多了，因为达克斯网我只有一开始测试，发现它功能实在太阳春了，我就放弃它了，我就直接跑去 Kubernetes 这样子。那但是其实对我而言的话，就是 Kubernetes 它在可能我会后可以再讲，就是它 Kubernetes 它的 path 里面，它可以有很多 container 这件事情，它其实在container 跟 container 之间的沟通联系的时候，其实跟 Docker Swarm 它有点差距。那我觉得因为这个有点太细节，我们或许可以会后稍微再跟有兴趣我可以跟你讨论一下这样子。
我之前装过 Docker Swarm， 很简单，但是我们在市场上或者是在新闻上没有看过任何一个用 Docker Swarm 推出他自己的产品，但是 Kubernetes 有 ，Pokemon 它就是一个 example， 所以我觉得在稳定度上，这个应该会有很大的一个差距在这个上面。那另外一个就是，其实刚才他们所说的，就是其实 Kubernetes 其实在一个很大量的社群在这边 develop， 所以它进步的很快，可以看到 1.6 前几天多久之前才发布，可是你看刚才金山所报告它的测试的数据，它的每一个 communication 之间的描述很短，它可以承受更多的 node， 可以承受更高的 container， 可是我没有在 Docker Swarm 里面拿到这个数据。这个是我目前所看到的，虽然我没有去查，但是我觉得会后如果有兴趣，我们可以去 Google 一下，看是不是在 Docker Swarm 里面他们有他们的一个测试数据，到底在用在哪些产品上面，哪些公司在用 Docker Swarm 来做这件事情。那如果各位有兴趣，可以去装一下，其实两三行指令，基本上它就可以 set up 一个 cluster， 这是我的经验。
那我稍微帮大哥说简单一点话了。其实，在网络上的一些讨论啊，有人是有说到说，就像刚刚那个说的，他的说真的比较好装，然后它也就是比较简单使，比较好用。也就是说，对于一个在早期啊，在 Kubernetes 在 1.2 的版本的那个时候，好，那就有人也是就提到说，我学习门槛比较低，我很容易就可以学会操作使用。可是随着时间的演进，我一开始也讲过嘛，那个社群的力量嘛，它的 community 真的就没有人家大，然后发展速度没有人家快，所以就随着时间拉长之后，就是在function上面基本上已经说太多了，包含你像 Kubernetes 我们基本上大部分虽然我们网络都是用 Flannel 啦，可是有时候你如果真的要跨网段的时候，或是你要走 hybrid 的时候，除了 Wave 跟 Critical 以外，它其实 Kubernetes 还有更多的网络的一些套件可以让你学，这些都是 Docker Swarm 所没有的。然后再来就是 Scalability， 这个也是真的就是差了一大截啊。那所以说，真的要我评价，简单的一个结论就是 Docker Swarm 真的就是入门门槛低而已。可是你如果只是要拿来玩一玩是还 OK， 你真的要给他学的话，你会发现真的不太够。对。
你好，我名叫利亚，我想先问一下几个问题哈。第一个就是目前的 Kubernetes 是不是可以 support 不同 type 的 containers， 可以就是说不同的 containers 可以让你这个被 managed by Kubernetes manager， 这是第一个问题。Hello, okay. My second question actually is just try to understand, to learn about OCI can support or can convert all other containers to be compliant with OCI standard. That's a question to Ian. 第三个问题，不好意思问的有点多，就是现在是不是以 production 环境而言，Docker 或者是任何的 container with 这个 Kubernetes 可以适合真正做一些比较 scale 比较大的 operation， 或者是特别是在 transaction 或者这些 services 上面。谢谢。
那据我所知，那目前的话，它是可以支援 Docker， 也可以支援 Rocky， 这两个主流的 container 它都可以跑。对，那这是我目前所知道的部分。我不知道今天这边有试过其他的，或者是那个有试过其他的 container 在 Kubernetes 上跑。
基本上我们大概测这两个，可是我们另外测的是测平台啊，就是基本上我们有另外这个，就是可以让你在x86跟 ARM 的系统上面都可以跑。
Yeah, I guess I can maybe speak to the second question that you had, and around converting different container formats into OCI and making so that they're compatible, and that is definitely something you can do. The tool that they used that's built by some people at Red Hat during the presentation called Scopio. Will actually do that, so it will take a Docker image and convert it to OCI. But there are some things that you have to there are some caveats to that. It's not going to convert it completely 100%. Like it convert the file system okay, and things like that, but some of the metadata that Docker uses as part of their container format won't really be like translated one-to-one into OCI, right? So like in Docker, they have a lot of metadata, so say things like health check metadata. So like inside of Docker images, or like in your Docker build file, you can say like health check, something, and like in order to create some metadata inside of the image that says I should have a health check here, right? But that's something that's like, say, OCI or other, the OCI format would say is basically out of scope of the image format itself, right? That's something that an orchestrator can do on top of that, that you can set up on top of that, but that's not something that the container itself is really responsible for, or the container runtime is really responsible for. So those type of things may not be one-to-one compatible, right? You can't expect that all of the